it really shows how science benefits us as a society, right? It's like the process is always fundamental science needs to happen first to show the base case. It's possible and it's worth it. Once you have that, then you go into, okay, how do I industrially scale this thing? How do I make it better? How do I make it cheaper? Blah, 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 you know?
So chemistry was our last prize that we covered last
Yes,
week.
this was for metal organic frameworks. Omar Yagi specifically, we're going to focus on some of his follow-ups. He made MOF5, which was the really big deal, metal organic framework, right? This thing had a single gram, had several football fields worth of surface area. So MOFs are created by this process called solvothermal synthesis. You get these crystals, which they kind of look like this under the microscope. They're tiny, tiny amounts, grams at a time. The real challenge now is scaling this thing industrially.
I do remember one comment saying like, "Well, can you produce it at industrial scale?"
Yeah, and it's difficult. There's a lot of difficulty here. First of all, the DMF, which is a common solvent that's used, this thing is toxic and it's expensive. So we'd rather use stuff like ethanol or water. The yield is pretty small. And if you scale up, then you can imagine the crystals are less good because the environment is not completely uniform. The bigger the vessel, you're going to have like edge effects, right? Where the edge temperature is different from the central temperature. The pressures are different. Removing that solvent is pretty hard at larger and larger scales because what you have to do is basically vacuum pump all of that stuff out, and producing a big enough vacuum pump for industrial scale is pretty hard. I did find a company. There's several companies, but there's one company I wanted to highlight, Novo MOF. They're a company out of Switzerland. We're not sponsored by them or anything, okay? But it's a cool company that I found. They made 300 kilograms of their NMOF, and that 300 kilograms has 240 kilometers squared of surface area, which is like the size of cities.
Right.
And they're using this for carbon capture in factories, right?
Yeah. What's interesting is the concept of metal organic, like most of the Nobels, the discoveries have been made quite some time ago.
Yeah.
And, with metal organic frameworks, we're at a place now where they've been experimentally proven. There's a variety of different methodologies that have kind of been identified.
Yeah. There's been also the rule book on how to make stuff, right?
And so now the challenge is going from making a meal for me, you, the spouses,
to like McDonald's level.
To McDonald's.
Yeah.
How do you make this enterprise, industrial grade, volume, size, scale, which again is non-trivial, but is the tail end of this sort of fundamental research to end consumer product cycle.
Yeah, exactly. And